Okay, so my values for A was 5, B was 8, C is 15, and D is 20. So to find the domain and range of this function, I'll start with the domain and range of the parent function. So the domain of the parent function of y equals cosine inverse x is negative 1 to 1. So to find the domain of this function, we must use the horizontal and vertical stretches in this equation. The B and C values are the horizontal shifts. So the B value of the horizontal dilation is 8 right here, and the C value is 15. When working with horizontal shifters, we must use the inverse of what we state in the equation. So since we're multiplying 8 by this, we have to divide by 8, and since we're subtracting 15, we must add 15. So right here, I start with the 1 divided by 8 plus 15, which gives us 119 over 8, and do the same thing. 1 over 8 plus 15 equals 121 over 8. So that is the domain 119 over 8 to 121 over 8. The range of the parent function is 0 to pi, and we use a very similar process as we did similar process to the domain. Except this time we use the A and D values of the function. But when we use these values, we actually use what is present in the equation. So the amplitude is 5, we will multiply by 5, and then we'll subtract the pi over 20. So we always do the dilations first in the shifts, because if we do, we will not get the correct. If we do not do that, we will not get the correct results. So 5 times pi over 1 minus pi over 20 gets 99 pi over 20, and 0 minus pi over 20 equals negative pi over 20. So that range is negative pi over 20 to 99 pi over 20. Next, we do the same process for the inverse secant graph. Literally the exact same thing. Start the parent domain and use the shifters. So the domain of the original function is negative infinity to negative 1, u 1 to infinity. So since you see how 1 and negative 1, we use those up here, so we don't have to go through the same process, but I did to show the work. So we have negative 1 over 8 plus 15 over 1. It's 119 over 8. We do the same thing down here. 1 over 8 plus 15 over 1 equals 121 over 8. And we plug those into the correct values. Infinities stay the same because it's just infinity. And the reason these are the same is because we still have the same shifts. We still have the same B values and C values. So the values will be the same. And in the range, we use the exact same process this time, but since there's an asymptote, we must use it on a third value. So we have to do 0 times 5 is 0. So 0 minus pi over 20 equals negative pi over 20. We do 5 times pi over 2 minus pi over 20, which is 49 pi over 20. And 5 pi over 1 minus pi over 20 equals 99 pi over 20. As you can see, these are the same values as above right here, the n values. The n values of these are the same values that there above. Alright, as you can see in the domains, the inverse secant graph does not exist where the inverse cosine graph exists. So basically, the graph exists in between these points for the domain, and for the secant graph, the graph goes there, stops, and then picks up at the end. As you can see right there, they're different. They're different located. This is because this secant is the inverse of cosine. Like I stated earlier, the inverse cosine graph does not exist where the inverse cosine graph is, except the inverse cosine domain range endpoints. For the range of the cosecant graph, there's an asymptote at 4920. This is 49 pi over 20. This is because the cosine graph exists where the asymptote is at. Both ranges contain pi over 20 and 99 pi over 20. They're both used as a starting and ending points. These points are in the domain. These points are starting and ending points, and down here they're points of where the graph ends and then jumps back in.